In this video, we'll explore uniform motion. Now, uniform motion is talking about an object that's moving at a constant or average speed. For example, you're driving down the highway, you're going 70 miles an hour. You don't think about all those individual speeds as you go up and down, but the average speed. This allows us to use the distance formula, where we know that the distance we travel is going to be equal to our average speed times the amount of time we've been traveling. Now, it is important to recognize that our speed and our time have to have the same unit of time. So if our speed is in miles per hour, our time that we discuss must be in hours as well. So we may have to convert time. When we're trying to solve uniform motion problems, we want to read through the problem and try to figure out what is it that we don't know so that we can solve for that specific component. So it's either going to be our distance, our rate, or our time. We then determine what information is given to us to help us set up this equation and solve for our unknown. We then want to solve the problem, but also look at our solution and put it back into the context of the problem to make sure that it does make sense. Now, if you have to convert time, what we're going to do is we're going to use proportions using one of the ratios often that we have here. The relationship of seconds to minutes, or to hours, to days, or to years. So say that we need to convert 45 minutes to hours, because we're dealing with, say, miles per hour as our speed. Well, we're going to use the ratio we know, which is that for 60 minutes there's 1 hour. So if I set that as a ratio, 60 minutes over 1 hour, that's going to equal, well, now I'm going to plug in what information I was actually trying to use. 45 minutes for some number of hours I don't know yet. Since it's a proportion, I can cross multiply, and that's going to give me that 60x is equal to 45. Now when I divide by the 60 minutes, what I notice is that my units of minutes go away, and I have equivalent measures of units left. My x hours is going to equal 45 over 60 hours. And that's what I want. I want those units to be equivalent. So if I simplify 45 over 60, I get 3/4 of an hour. Now let's look at some examples of using uniform motion. Terry's needing to make an important meeting at 10 a.m., but she accidentally slept through her alarm and woke up at 8:15. She knows the meeting is about 84 miles away, and she can leave the house by 8:30 if she gets dressed quickly. If the road she lives on goes about 60 miles an hour, can she make the meeting? So we got to think about what is it that we want to know. And what we want to know is how fast does she have to go to make the meeting by 10 a.m. So we're looking at that minimum speed she would have to travel. Think about what we do know. We know that she has to travel 84 miles. And we know that she's going to leave at 8:30 and show up at 10 a.m., and that's an hour and a half. So we want to write that, since we're going to be dealing with miles per hour, in hours, so 1.5 hours. Now we can use our distance formula. We know our distance, we know our time, and we're going to solve for the minimum speed we would need to travel. We divide both sides by that 1.5, and we get 56. Now what does that mean? Well, what that means is that she would have to travel a minimum of 56 miles an hour to arrive at the meeting by 10 a.m. Well, since she can go 60 miles an hour, she can travel a legal speed limit and should make it there with several minutes to spare. Now let's look at another example that you can see with uniform motion, which is this idea of catching up or chasing. So say that Ben goes out for a bike ride going about 20 miles an hour. And after 30 minutes, Bailey sees that Ben left his water bottle. So she goes after him because she doesn't want him to get dehydrated, and she's able to go 50 miles an hour. So two problems you may see is how long will it take Bailey to catch Ben, so a time, or how far did Bailey have to travel to catch Ben? So let's look at just the first one. How long? So this is in relationship to Bailey. How long does it take her to catch Ben? And so since we're dealing with miles per hour for our unit, we need her time to be in hours. Now a key word here is that idea of catching up. And when we catch up, that means that we've traveled that same distance from our original destination, which was their house. That means the distances of both Ben and Bailey have to be the same. And that allows us to set up a unique equation. So let's use our distance formula. We know that our distance will be in miles, our rate has to be in miles per hour. That means the time has to be in hours as well. That's an important thing to pay attention to. So say that Bailey, we know, is going 50 miles an hour. We don't know how long the time will take her. So we know her distance would be 50 times t. Now let's look at Ben. Ben, we know, was going 20 miles an hour. We know he travels the same amount of time as Bailey, but he left 30 minutes earlier. So he traveled an additional 30 minutes, but in relationship to hours, we would say that would be an additional half of an hour, so t plus 1/2. So his distance would be 20 times t plus 1/2, that quantity. Since they traveled the same distance, we know these two expressions have to be equal. Now to solve this, we distribute the 20, and that gives us 20t plus 10 equals 50t. We want to get t on the same side, and then we divide by 30. And we get 1/3 of an hour, which is about 20 minutes. So it would take her about 20 minutes to catch up with Ben riding his bike, which would make sense since she's going over twice his speed. Now the other question that was asked is, how far did Bailey travel? Now we know how long she traveled, and now we want to figure out how far. So we can use the distance formula again. We know her speed, and we know her time, which was 1/3 of an hour. If we put those pieces together, we can figure out how far she traveled. So 50 times 1/3 for that 1/3 of an hour. Again, we can't use 20 minutes because 50 is in hours. So we have to use the 1/3 of an hour. And that gives us 50 thirds, which we simplify and get to 16 2/3 miles.